with me, Mr. Koenig, again, coming to you to help you out with 2.1.4. 2.1.4 is really about simplifying algebraic expressions, and we're using zero pairs as the method to actually do that simplification. So I'm going to demonstrate how this would work with your initial problem. There's really three steps to doing this. 1, 2, 3, you see there. 1 is write the original algebraic expression. 2 is make zero pairs to simplify. And 3 is write the simplified algebraic expression. All right, so step 1's pretty straightforward. Couple reminders. If you have a shaded tile, it's a positive tile. If you have a white or not shaded tile, it is a negative tile. So I'm going to start by looking at the upper or positive area in the expression mat below. I noticed I have 2 positive x's, so I'm just going to start with that. I notice I have a negative x, so I'm going to say plus negative 1x. I also have a single positive unit tile up there, so I'm going to say plus 1. And then I need to look down in the bottom or negative area. And I do have, it looks like 3 positive tiles down there, except remember where they are living makes a big difference. They live in the negative area, that makes them negative 1, 2, 3. So that's minus 3. So that is how you look at an expression mat with some algebra tiles on it and actually write an algebraic expression. That's the original one right up there. Okay, now we're going to make zero pairs. So zero pairs basically it would be 2 tiles that when you add them together are 0. So what I typically do is I'm going to concentrate on just the positive area right now. If you look in just the positive area, you look for tiles that would be sort of opposites. So a shaded X and a not shaded X. That's positive X and negative X. That's 0. No matter what X would be, right? X could be any number, but let's just say it was something simple like 5. If X was 5, then 5 and negative 5, 5 minus 5 is 0. We know that 0, when you add 0 to anything, it doesn't affect that number. If you had 5 and added 0, you would still be at 5. So we can actually get rid of anything that makes 0 on this mat. What you do is just kind of circle. Now let's draw an arrow like it's leaving, like it's not there anymore. Now you'll notice that other positive X doesn't have a partner or a zero pair to go with it, so that just stays there. Also, you will see that positive unit tile in the top or positive area. It doesn't have a not shaded or white unit tile to go with it up there, so for now it stays there. What we have to do though is think about, so some teachers will have you flip, and I'll have them demonstrate that for you. We didn't get to it yet, but there's a method where we can flip these tiles to the positive area. For now, what I like to do is actually think about what each tile is. So this right here is a positive tile living in the positive area. So that's positive 1 right there. If you think about like this tile right here, although it looks like it's positive, you have to remember where it's living. It lives in the negative area. So that's actually negative 1 that I just circled. So if you think about it, you have a negative 1 and a positive 1. That is another 0 pair. So you can also take that off. At this point, I don't see anything else that I could pair up as a 0 pair to take off of the mat. So I think my simplification is actually done. Quick hint, if the tiles are opposites like shaded and not shaded and they're in the same area, you can take them off. If they are exactly the same but live in opposite areas, like one's in the positive, one's in the negative area, those are also zero pairs. So that's a good example of both of those situations in this problem. So now we get to step 3, write the simplified algebraic expression. We just read the tiles we have. We have an x up top, so that's x. And then we have 2 positive tiles, but living in the negative area, so that is minus 2. There's the simplified algebraic expression. So 3 steps. Write out what you see when you first get your algebra mat or your expression mat. Simplify with the 0 pairs like I showed you right here. And then write what you have left. In this case, I got x minus 2. All right, so that's one way that you're going to see problems today. Another way, so when you get to 238, I put reference this for problem 238, just like those. All right, so another way you're going to see this is you're going to actually have to build the tiles. All right, in this case, you can draw them, remembering that shaded is positive tiles. So if we have shading, that equals positive, and not shaded, could be a unit tile, could be X, whatever, equals negative. All right, so all you got to do, step 1 for this type of problem, for like, you're going to have to do this in 239B. So when you get to that, here's a good reference point. I'm going to draw my tiles in. So I have 3 X's to start out with. Notice it's not going to be perfect. Those are X's, and I'm going to shade. Just shade around the X's so that we see that they are indeed positive. So there's 3 positive X's, not perfect, but we can see that. All right, so I took care of this part right here, 3x. Now you'll notice that it is telling me that this whole group, 2x plus 4, should live in the negative area. If you look in front of this parenthesis, so you see the parenthesis up top, 2x plus 4 is in the parentheses. In front of that is actually a minus or a negative symbol, however you want to think about it, what makes sense to you. That means you should build that whole collection in the bottom or the negative area. So I'm going to build that I just circled in the negative area. So 2x's. Those will be shaded. And 4. And again, that's a positive 4, but they're just going to live in the negative area, which will then make them negative. All right, so I accomplished step 1, building the expression. All right, now I got to simplify by making 0 pairs. Show work. Okay, that means you just got to circle things, show things going off. If you recall from the last slide, I basically said if the tiles are living in the same area and the opposite of each other, like shaded and not shaded, that would be a 0 pair. But also, if they are exactly the same and live in opposite areas, so like you'll look, this X and this X are both shaded X's or positive X's, but they're living in opposite areas. One's up top, one's down below. So up top, that's a positive X. Down below, that's a negative X. Put those together, positive X, negative X, that's a 0 pair. So that comes off. And you'll notice right next to it, we also have a second 0 pair. That also comes off. I don't see another 0 pair up top. There's no other negative X up top in the positive area to take anything else off up top. And also down in the negative or basement down here, there's just 4 positive tiles living in the negative area. So that's actually -4. And that's about all we can do. So we did step 2. All that's left to do is write the simplified expression. I will start with x, and then we'll see people make this mistake. They're going to put plus 4. It seems like they should be positives because they're shaded, but you got to remember where they live. They live in the negative area, so they're negative tiles. That's minus 4. Okay, that is that. That's the 2 type of problems you're going to see today. Please ask your teachers if you need more assistance. Go back and rewatch these videos as you're working on the problems. All right, goodbye now. Enjoy math for today.